So now this video will be talking about how we can add, subtract, divide or multiply fractions, and basically for the beginners. So we want to use the concept of the literary addition, subtraction, multiplication and division of the actual fractions, and just that then you'll be able to understand what it means in the algebraic actually the fractions. But before we go further, I want you to understand about what is a fraction. So if we say a fraction, it is the combination of the values, or we can call them as the numbers or the terms, whereby one becomes the numerator and the other one becomes the denominator. That is a fraction. For this case, we can have, let's say, 2/5. This is the fraction where 2 becomes the numerator, and for this case 5, it is said to be the denominator. So that is the fraction. So fraction is more characterized by having the numerator as well as the denominator. That is a fraction. And let's say if we can have x/m, this is also the typical fraction, where this is the numerator and this is the denominator. And if we have, let's say, x plus 2 divided by, let's say, 5, this is also a typical actually a fraction. And we have actually two types of fractions. We have what we call as a proper fraction. We have what we call as the proper fraction. So by the way, another component of the fraction, it is said to be the whole number. So what is a whole number? In this case, let's say if we have 5 divided by 2. In this case, this is a typical fraction where this is the numerator and this is the denominator, like that. But the numerator is the denominator is less than the numerator. So if that is the case, then using the long division method, we can have 5 divided by 2. What is 5 into 2? So in this case, 5 into 2, it is given as 2, and 2 times 2, which is given as 4, and 5 minus 4, it is given as 1. So in this case, what we have, this is a remainder which is given as 1. Now in this case, this can be presented as 5/2, can be presented as having it as 2, which is this, and remainder divided by 2, which is that. So what we have, this 2 is said to be the whole number. So it is said to be the whole number. So in this case, let's say if we have 10 divided by 7, using the same way, we'll have it as 1 and 3 divided by 7. So where 1, it is the whole number. So a fraction can have the denominator, numerator as well as the whole number. So we have two types of fractions. We have what we call as the proper fractions. So what are the proper fractions? Now if we say proper fractions, these are the fractions with no whole number. Those are said to be the proper fractions. These are the fractions that do not have the whole numbers. We can have, let's say, 5/2, this is the proper fraction. We can have, let's say, 1/2, that is the proper fraction. And let's say 10 over should be, let's say, 37, this is a part of the proper fraction. And even, let's say, 1/6x, this is also the part of the actually proper fraction. And another name for the proper fraction, it is unmixed fractions. And now we have another type of the fraction, which is said to be the improper fraction. We call them as the improper fractions. So what are the improper fractions? Now these are the fractions that contains the whole number, and we call them as also the mixed fractions. We can have, let's say, 2/1/5, that is, we can have, let's say, 10 2/7, that is that one. We can have, let's say, 5, let's say 6 should be 10, that is an example of the improper fraction. So keep that in mind. And let's see how we can add or subtract the fractions. Now, whenever we are adding or subtracting the proper fraction, I should say, whenever we are adding or subtracting the proper fractions, the point of interest has to begin with the denominators. Let's say if we have 2 over, let's say, 5, and a plus, let's say have 2 over 6. So how do you think we can add these two fractions, if that is the case? So the point of interest has to be done by looking at the denominators. So in this case, we have two denominators, that is 5 and 6. Then we should have to decide which number 5 and 6 can enter into without leaving a remainder. And that number is said to be the common denominator. So before we go into the detailed structure about the addition or even the subtraction of the fractions, I want to go much in details about how we can be able to deduce the common denominator for the given denominators. So let's skip it first. Let's say we have 5 and let's say 2. Assuming that these are said to be the denominators of the certain fractions. What do you think is the common denominator for these numbers? So what is the number in which 2 and 10, I should say, what is the number in which 2 and 5 can enter into without leaving any remainder? So the common denominator for 2 and 5, it is given as 10. That's the lowest possible number in which 5 and 2 can enter into without leaving any remainder. And let's say if we have, let's say 5 and 15. What is the number in which 15 and 5 can enter into without leaving any remainder? So in this case, the lowest possible actually a denominator for both, it is given as 15, because 5 can enter into 15 and 15 can enter into 15. That is okay. And how about let's say if we have something about, let's say 7 and let's say we have 4. So what do you think is the common denominator for this? So the common denominator is given as should be 28. Because a 7 can enter into 28 and even 4 can enter into 28 without leaving any remainder. That's the lowest possible actually the common denominator. Now what if we have the common denominators that involves the variables? Let's say if we have 2x and versus let's say we have 6. So what do you think is the common denominator for these two actually denominators? So here we have a number 2, here we have a number 6. So first thing we should have to consider actually those numbers. What is the common denominator for actually 2 and 6? So it is given as 6. And here we have x and here there's no x. So have x as also part of the common denominator. And despite that, here it is x, here there is x, and here there is no x. But since x is available on since x is available on one part of the actually denominators, then we just have to include it as part of the common denominators. Let's say if you have this. What did you say? Let's say if we can have something like this. Let's say if we have 2m n and versus let's say 15, that should be xm. How do you think we can have, let's say we should have it as n square. So how do you think we should have the common denominator here? So we have the numbers 2 and 15. First thing, we should have to consider the common denominator for those numbers. So what is the common denominator for actually for 2 and 15? We'll have it as 30. Then here we have m and also there is m here, so have it as the common denominator as well. Here we have n raised to the power 1 and n to the power 2. Now in this case the common denominator will be the variable, will be the one with the highest degree power, which is n to the power 2. So this will be the common denominator. How about if we have this? Let's say if we can have, should be 6 m to the power 4 x to the power 5 Let's say if we have, and that should be that of m to the power 2, x to the power, let's say 2, and that should be, let's say, n. So what do you think is the common denominator here? So we have a number 6 and there's no number here, and of which it is there is a coefficient given as one, of which that is the case. So what is the common denominator for 6 and 1? So we have it as a 6. Then we have m to the power 4 and m to the power 2. The one with the highest degree power is the common denominator. Then we have x to the power 5 and x to the power 2. The one with the highest degree power is the common denominator. Then here there is n, here there is no n. We'll have it as also part of the common denominator. And also try to deduce the common denominators for the following on your own. Let's say if we have 10 and versus 20. And let's say if we have 5 and let's say 30. And let's say if we have x to the power 5, y to the power 4, and let's say half n square. We should have that. And let's say if we have 2 m to the power 5, x to the power, let's say 3, and versus, let's say, z to the power 6 and x to the power 4. How do you think we should have the common denominators for those? So try to have those actually on your own time. Now let's see how we can add or subtract fractions. Let's say if we have 2 over 5 and plus, let's say, 1 over 2. So how do you think we can add these two fractions? So in this case, first thing, we'll have to present the horizontal line in this case, just down the denominators. Then what is the common denominator? The common denominator, it is given as, should be 10. And what is 2 into 10? That is given as 5, and 5 times the numerator for 2, that is given as 5. And the plus 5 into 10, that is 2, and 2 times 2, that is given as 4. So in this case, we'll have it as 9 divided by 10. So that is the solution. And how about, let's say, if we have this? Let's say if we have 2 1 over, let's say, 5 plus, let's say, 3 2 over 7. So how do you think we can have this? So what we have, these are the actually mixed fractions. So these are the mixed fractions, and we should have to express them to be, proper fractions. So what is the principle behind? We'll have 5 times 2, which is 10, and the plus 1, that is 11 over 5. And the plus 7 times 3, 21. 21 plus 32, what is that? That is 23. And then divide by 7. Then we'll take it from here, we'll have it as, what is the common denominator? That is 35. And the price here, then actually 7 into 35. That is given as, should be 5, and 5 times that of 23, we'll have it as 115. Like that. And 5 into 35, that is 7. 7 times 11, that is 77. So what is, and that should be 77, and that plus 115, we'll have it as 192 divided by 35. Now since the numerator is greater than the denominator, we can express that on to have the whole number as well. What if we have, let's say, this case? Let's say we have 5 over 3 minus, let's say, 1 over 2. How do you think you can have this? Principle means the same. What is the common denominator? Actually, denominator, we'll have it as 6. And 2 into 6, that is 3. The 3 times 1, we have it as 3. And minus 3 into 6, that is given as 2 times 5, that is 10. Then 10 minus 3, that is should be 7 divided by 6. So since the numerator is greater than the denominator, we can express that as a mixed fraction. So keep that in mind. What if, let's say, we have the following cases? Let's say we have a divided by m plus, let's say we have 6n divided by, let's say, should be x. How do you think we can simplify this? So by the way, what is the common denominator? We'll have it as mx. So what is x into mx? We have it as m, and m times 6nm, that is 6mn, and m into mx, that is x, and x times a, we have it as ax, and the plus here. Now these are the like terms, it will end there. It should be unlike terms rather, it will end there. And what if we have, let's say if we have 1 over x and a plus, let's say 1 over x plus 2. So how do you think we can have this? So principle remains the same. What is the common denominator? We have it as x times x plus 2. So in this case, we'll have x plus 2 into x times x plus 2. We have it as x, and x times 1, that is x, and a plus x into this, we'll have it as x plus 2, and x plus 2 times 1, that is 1 times x plus 2, like that. And we have to distribute 1, that will be given as, 1 times x, that is x, and should be 1 times 2, that is 2, and plus x divided by x times x plus 2. So in this case, the like terms will have it as 2x plus 2, and then divided by x, that is x plus 2. And of course, we can factorize on top there. We'll have it as 2 and x plus 1, and then divided by x times x plus 2. So we'll have that. So how do you think if we can have this? How can you have it then? Well, let's say if we can have it as, that should be y plus x divided by, should be x, and the plus, let's say we have y over 2x. So how do you think we can have to add these two fractions? Principle remains the same. What is the common denominator? We have it as 2x. Then 2x into 2x, that is 1, and 1 times y, that is y, and the plus x into 2x, that is 2, and 2 times, we have 2 times y plus x. So have to distribute 2, have it as 2y plus 2x, and plus y divided by 2x. So having the like terms together, we'll have it as, should be 3y plus 2x, and then divided by 2x. So since these are unlike terms, we cannot take them further, or just have to leave it in that way. So what if we can have this? Let's say if we have x minus 1 divided by x, and that should be minus, let's say 2x plus 1, and that divided by, that is 3x. So how do you think we can have this? Principle remains the same. We'll have the common denominator, which is 3x. 3x into actually 3x, that is 1. And 1 times we have 2x plus 1, like that. And then we have minus here. Then x into 3x, that is 3. And the 3 times x minus 1, like that. Then we'll have to distribute 3. We'll have 3x minus 3. Then a negative times positive 2x, that is negative 2x. Negative 1 times positive 1, that is a negative 1. And which is divided by 3x, like that. So 3x and negative 2x, those are right terms. We'll have x and the negative 4 divided by 3x. So that's how you can make it in that way. So keep that in mind. And what if we can have this as well? And appreciate, let's say if we have mn and over 4, and that should be minus, let's say 1 over 3 my. Now you should have to understand that if we have, let's say 2 over 5, let's say xy, you should have to know that this is the same as having it as 2xy over 5. It is the same as that. So in this case, you should have to keep in mind that, having 1 over 3 my, it is the same as having it as, mn over 4 minus 1 times my, which is my over 3. So what is the common denominator here? We'll have it as 12. And the 3 into 12, that is 4, and 4 times my, that is 4 my. You have minus here, 4 into 12, that is 3, and 3 times my, that is 3 ma. So these are unlike terms. We cannot simplify them, we just have to leave it in that way. Now what if we have something like this? And see how we can make it up. Let's say if we have 3 m minus n divided by, let's say if you can have 5 mn, and minus, let's say 3 minus, it has to be minus 7 here. Let's say minus 7 divided by 6n. How do you think you can have this? You know what is the common denominator? We have it as 30 mn. So in this case, 6 into 30 mn, that is given as 6 into 30, that is 5. And n into n, that is 1. Then we have it as, should be 5m. It should be a 5m times 7, that is 35m. And the minus here, and the 5mn into 30mn, that is should be 6, and 6 times 3m minus n. Then we have to distribute 6. That will be given as 18 mn, should be 18n, m minus 6n, the minus 35m. Write that divided by, we have 30mn. Then we need to have the like terms, that is this and that. How do you think you can have it there? So have, 18 minus, and there should be 18 minus 35. That will be given as the negative 17. Should be negative 17m minus 6n, which is divided by 30mn. So that is. And what if we have this case? And see how we can make it up. Let's say if we have something about should be, let's say if we have x and a minus 2i, rather should be minus 2i, and let's say divide by, should be 6. In the minus, we should have it as 2i minus x divided by, has to be 4. So what do you think is the common denominator here? So in this case, we'll have it as, should be 12, and 4 into 12, that is should be 3, and 3 times we'll have negative 3 here, and 2y minus x. And 6 into 12, that is 2, and 2 times we'll have x minus 2, y, like that. Then we have to distribute 2, have it as 2x, and minus 4y minus 6y plus, should be 3x, which is divided by 12, and take it from here. So try to have the following in your own case. You should have to look at, let's say if we have a over, there should be 3, and plus, let's say if we have 2 minus, has to be 1 over 4. And I should also have this as well. Let's say if we have, that is 2 over, should be 3 over 2x, and plus 2 over 2x. We should have that one. And let's say if we have this other case, and which is, let's say 2b, and plus 3 divided by, let's say 6b, and which is plus, let's say 3a minus 2 divided by, should be 6n. How do you think you can have this? Let's say if we have, let's say if we have it as, let's say if we have 6x minus, let's say 6m, now which is divided by 3, write that in the minus, and let's say minus 2b, and divide by, let's say 6m. How do you think you can have that? And also try the following. Let's say if we have, and that should be m over g minus, let's say 3m over should be 2d, and that plus, let's say 5mn, and that divided by should be 5d. How do you think you can have this? And let's say if we also have this as well, let's say 4 over p, and minus 5p over 2, and plus, let's say 3 over 4p. How do you think we can have that? And let's say if we have something about, let's say 2b's minus 3, and say divide by 4 minus 1 over, let's say 3c. How do you think we can have to simplify that as well? And what if we have, let's say 5c and minus, let's say m minus 2 divided by should be 4? How should we have that? Now there's something you should have to understand as well. And what is that? If we have, let's say x, this is the same as having x divided by 1. If we have, let's say 5, this is the same as 5 divided by 1. That is how we express that one as a fraction. Let's see how we can subtract, to say, let's see how we can multiply or divide algebraic fractions, if that is the case. Let's say if we have, let's say, by the way, you should have to understand that, let's say if we have m over n, and it times, let's say, x over y. You know, you should have to understand that this is the same as having it as mx divided by ny. And likewise, if we have, let's say, m over n, you know, times, let's say, xn divided by, there should be that one of my. This is the same as having this being cancelled. We have it as that. This is the same as having it as x divided by y. In that way, in other ways, we can have to cross cancel this like that. And also, actually, likewise, if we have, let's say, a over b, you know, divided by, let's say, m over n, you should have to understand that this is the same as having a over b and that divided by m over n, you know, which is also the same as a over b times n over m. In other words, whenever we are dividing the fractions, whenever we are dividing the fractions, the fraction which is to the right hand side of the actual division sign has to be interchanged, in the sense that the denominator has to be the numerator and the numerator has to be the denominator, like that, and the sign has to change as well. That's the principle behind. And let us see how we can have to simplify the fractions in terms of division as well as the multiplication. Let's say if we have 4a divided by, let's say, 9 times, that is 3 over 2. So how do you think we can have this? So it is possible to cross actually cancel. In this case, we have 3 into 3, that is 1, into 9, that is 3, and 2 into 2, that is 1, into 4, that is 2. Now we have it as, that is 2a, you know, divided by 3 times 1 over 1, which is the same as 2a divided by 3. Have that. And let's say if we have 12 divided by, and there should be 7x times, let's say if we have 3 over 2. So in this case, we can be able to cross cancel. In this case, we have 2 into 12, that is 6. Here is given as 1. This is the same as 6 divided by 7x, and at times 3 over 1. So in this case we'll have it as 18 divided by 7x. So that is the solution in that way. What if we can have this? Let's say if we have 4p, that which is divided by 5, then divide by, should be, let's say, 12p, and our over should be 25. So how do you think we can have to simplify this? So in this case the fractions are dividing. So in this case this is the same as having it as 4p divided by 5 and times 25 divided by 12p. So cross cancel, we can have 5 into 5, 1 into 25, that is 5, and a p into p, that is 1, 1, like that, and a 4 into 4, that is 1, into 12, that is 3. Now what we have is we have 1 over 1 times 5 over 3, which is the same as 5 over 3 in that way. And how about, let's say if we have this, let's say if we have 3pq, that is 3pq, and over should be 14, and that is divided by, let's say we have 12q, that divide by 7. How do you think you can have this? So in this case we have it as 3pq divided by 14, and that is times 7 over should be 12q. Then take it from here. So you can finish that one. And let's say if we have this, and try the following and appreciate. Let's say if we have something about 12ab, and let's say over has to be 11mb, and I divide by, let's say we have it as 4a divided by, that is 33. How do you think you can have that? And let's say if we have number 2, that is a 14 RS, and I divide by 33 as well, that which is 35 RST, and over 22. How do you think we can have that? And also, what if we have something about 3 over 20? Of what is the meaning of that one? So of, it is the same as multiplication. So try to see how you can best work out on that. And also how you can have this, appreciate. Let's say, what if we have something like this? Let's say if we have 2x and then minus 2 divided by, let's say, x squared, and also divide by, let's say, x minus 1 divided by x. How do you think we can have that? So in this case, you should have to understand that this is the same as 2x minus 2, and I divide by x squared, and the times x over x minus 1. So first thing you have to check if we cross cancel can work. So in this case, x into x1 and 2x squared, that is x. Now in this case, you can see that if we factorize this one, we'll have the component similar to this. So if that is the case, then we have 2x, that is we have 2, x minus 1, and then divide by x times 1 over x minus 1. So in this case we'll have to cancel this. That will be given as 2 over x. So that is the solution. So how about if we have this as well? Let's say if we have 8abc, that the actually should be over 15, there should be p square q, it has to be times 24c, that divide by 25 p's, like that. And what if we have, let's say this case, that is 2x squared, and over should be 3 divided by, that is 4 over xy. So how do you think we can have that as well? And also try this one as well and see how you can have it. Let's say if we have AB that divide by, that is 3 times A minus 2B, and that is times, has to be 24 AB divided by, that is 5 times A minus B. How do you think you can have that? So try that on as well. And what if you have this as well? Let's say if we have, and it should be about 12ax over, that is should be 15cx squared, and that is divided by, there should be 9cx divided by 10c square x square. How do you think we can have that? So that's how you have to understand about how we can simplify the algebraic fractions, and basically in terms of in terms of adding, subtracting, multiplication, as well as the division. That is for beginners. Thank you.